Hello everyone, this is Dr. Rajesh and I am again with you with my new video lecture, and this video lecture is on the topic directional derivative. This concept is very important concept as far as the vector calculus is concerned. So in this lecture we will try to just make some hold on this particular concept, and my main objective of preparing this lecture is to clear the concept in the mind of the students, so that once concept is clear, student could deal with any of the problem given to them in any of the examination. So today we will be dealing with directional derivative. At outset, a directional derivative is the derivative in the particular direction. So as the name indicate, directional derivative is a derivative in a particular direction. And in case of a surface, we know that del phi gives the spatial derivative, and in the earlier lecture we have seen that this spatial derivative is along the normal direction. This spatial derivative is in the normal direction, and we will again invoke the figure used in the previous lecture. So we will be using the same figure, so that we could relate the both lectures with one another, because the topic is directional derivative. So I am again taking help of the figure. So this is the figure, okay, and del phi is along the normal direction to the surface. So this is the direction of del phi, and this is any direction. So I would again plot it here, and this will be, say, the direction del phi, which is along the normal, okay, and this is direction A, okay, and you can write it as direction A. So what will you do? You will take the unit vector in that particular direction, and unit vector, say, is of this much length only. So this is, say, is the unit vector. So how will you take the directional derivative in the direction of A? You know the simple formula, and the formula is, take the component of del phi in the direction of A, and you know it is being taken by del phi dot A cap. This will give directional derivative of phi in the direction of A vector. So this is the concept of directional derivative. You will simply say del phi is in the normal direction, and if you want to take its derivative in any given direction, then take the dot product with the unit direction along that particular given direction. So that is as simple as this is. Next we will deal with the one problem based upon this concept, and the problem is given by, find the directional derivative of phi. So I'm going to write here as phi. Phi is given as x square yz plus 4xz square. At the point, this particular point, and at point 1 minus 2 1, and the direction, in the direction is given as 2 I cap minus j minus 2k cap. We have to find the directional derivative. Now we see that del phi we know, and we have to find del phi in the particular direction A. So we have to determine del phi dot A cap. So this needs to be determined. So let us find del phi. What will be del phi? We know del is an operator, and it is written as curly y k cap curly y curly z, and here you are going to write x square value of phi. So this will be value of phi. Now next, this will be written as curly by curly x square yz plus 4x z square plus j cap curly y x square yz plus 4x z square plus k cap curly by curly z x square yz plus 4x z square. So this thing is further equal to, this is partial derivative with respect to x, treating y and z as a constant. So if we will treat y and z as constant, differentiation of x here will be 2x. So here we can write as 2x, and yz are treated as a constant. They are treated as a constant. Plus, now again see, z is being treated as a constant, 4 is a constant. Differentiation of x with respect to x will be 1. So here will be 4 z square plus j cap. Now this means differentiation partially with respect to y, keeping x and z constant. With respect to y it will be 1. So here it will be x square z plus, it contains no terms of y, x is a constant, z is a constant, so differentiation will be 0. So you are going to write it as here 0. Now k cap, this is differentiation with respect to z, keeping x and y constant. Z is of x square, y differentiation of z is 1, plus here 4 is constant, x is constant, of z square is 2. So 2 into 4 is 8. It will be 8 x z. So this is equal to I 2x yz plus 4 z square plus j cap x square z plus k cap x square y plus 8 x z. Next we find del phi at point 1 minus 2 1. So I am going to put 1 in place of x, minus 2 in place of y, and 1 in place of z. So this will be 2 1 minus 2 1 plus 4. Fine. J cap, 1 square is 1 and z is, it is 1, plus k cap, it is minus 2, and it will be 8. So this will be I cap, it is minus 4 plus 4. Fine. Plus j cap plus 6 k cap, it is 0 I cap plus j cap plus 6 k cap. This implies that del phi at point 1 minus 2 1 is equal to 0 I cap plus j cap plus 6 k cap. Next we go through the A vector. A vector is given as, you see here that A vector is 2i minus j minus 2k cap. So I am going to take A vector as 2i minus j minus 2k cap. So now convert this into a unit vector, and we know that unit vector is vector divided by its magnitude. Vector is 2i minus j minus 2k cap divided by magnitude. 2 square is 4, minus 1 square is 1, minus 2 square is, and the square root. It will be 2i cap minus j minus 2k cap, and square root of 9 is 3. So this implies that, name it as equation number 1 and name it as equation number 2. We know that directional derivative of phi at point, and point given was 1 minus 2 1. This was the point, 1 minus 2 1, in the direction of A vector is equal to del phi dot A cap. Now you write the value of del phi. It is 0 I cap j cap plus 6 k cap dot 2 I minus j minus 2 k cap upon 3. Now take the dot product simply. 0 multiplied by 2 is 0, so this will be 0. Next will be minus 1, and it will be minus 12. It will be 3, so this will be minus 13 by 3. So this is the required directional derivative. Its value is minus 13 by 3. So in this lecture we have discussed the concept of directional derivative and dealt with an important problem based upon it. So in the next lecture very soon I will be with you. I will be again taking the directional derivative and some related important problems. So till now I have the all this from this lecture, and if you like the video, please like, subscribe, share and comment. Your valuable comment in the comment section are always welcome and appreciated. This is Dr. Rajesh saying you goodbye. Take care. Bye bye.